Here we've got an example of them wanting us to find a limit given an equation to work with. And so no matter what, I know that option one probably isn't going to be the thing that works here, but I got to tell you, you always have to try option one because every time you think it's not going to work, it ends up working randomly out of nowhere and it'll save you a lot of time. So option one is always go ahead and just plug whatever that x value is you're headed towards into the equation that they've given to you. And so here we'd be looking at limit as x approaches 0 of 7x over 1 over 4 minus x, just writing this thing out. And then when I go to plug a value in, I can drop that limit statement. And so I'd really be looking at 7 over 0, and on the bottom here, 1 over 4 minus 0 minus 1 over 4 plus 0. And what you'll see out of here is you're going to get 0, and then on the bottom you'll get 1/4 minus 1/4, and you'll get 0. And so the trouble spot is really that bottom 0 there, right? We can't do division by 0 in math. It's the biggest no-no in all of math. And so we come back and we say, okay, what's my next option? When you look at this problem, when you have fractions over fractions like this, or you're looking at what they refer to as a complex fraction, the name kind of says it all, right? Some crazy looking fraction setup that really only shows up on limit problems like this. That's going to be the method you want to go for. So when we see fractions over fractions, we're going to use this complex fraction method. And the first thing we do on the complex fraction method is we need to make this one clean fraction. So we need to get this to be one nicer looking fraction. So we do not want to see fractions over fractions. And what that's going to mean for us here is first and foremost, we need to combine that fraction on the bottom of this. So we need to combine this whole chunk down here. So to do that, you're going to need to find, addition and subtraction of fractions means find a common denominator. And so when you go to find a common denominator, should be limit as x approaches 0 still there as well. The common denominator, don't think about it as like the least common denominator, just you need to find a common denominator. And so what we do to find a common denominator is you are going to take whatever's on the bottom of one fraction and you're going to multiply it on the top and the bottom of the other fraction. And then guess what? You're going to do the same thing over here. So you'll take the bottom of this fraction and you'll multiply it on the top and bottom over here. And that's going to be the easiest way to find yourself a common denominator anytime. So as we rewrite this, limit as x approaches 0, our 7x is staying up top. Now as I go to put this together, I get 1 times 4 plus x, so that's going to get me 4 plus x. On the bottom here, I'm not going to multiply this stuff out. I'm just going to go ahead and keep it together in this format. So no need to multiply it out. In fact, if you do, it usually does more harm than good in these situations. So then we do again, multiply the top here. 1 times 4 minus x is going to get us 4 minus x, and then that's all over 4 plus x times 4 minus x. So now that we've got our common denominator, we can bring that together as a single fraction right there. And so starting down on this next line, you'd say, okay, this is limit as x approaches 0, the 7x stays the same, and on the top here now, we have 4 plus x, and then one of the critical moves is whenever you're subtracting something, it's always minus in parentheses that whole chunk. You're always minusing that full chunk. And if you don't put those parentheses, you're going to be off by a sign when you get to the end of this thing, and it will frustrate the heck out of you. So from here, it's, we're just cleaning up our algebra, right? A lot of these problems are really just a battle of wills. Like, are you going to give up before the math problem gets up? So we're going to bring together the top of this to, again, clean this into one fraction. So we get 4 plus x, and now I'm going to distribute this negative sign. That's a critical piece. So minus 4, and then negative is going to get us a plus x. And then on the bottom, we still have this 4 plus x, 4 minus x. Continuing on this cleanup path, we looked at that top part there again. I can cancel out, so I've got 4 minus 4, those are going to go away, and then I've got a plus x and a plus x, so that's going to get me 2x. So we've got limit as x approaches 0. Again, you got to keep the limit statements with you. You got to keep working through the algebra a chunk at a time. So now that we're here, now what we're ready to do is we need to do a rewrite. We need to do a division of fractions rewrite. On the top here, we've got a 7x, and really remind yourself that that's like having 7x over 1. That's really a fraction sitting up top there. And then we're dividing that by this bottom fraction. So when we go to do our division of fractions rewrite, different people have different sayings for how to remember how to rewrite this. The one that I like to use is copy dot flip. So you're going to copy the top fraction, which is just 7x over 1. So we're just going to call that 7x. We change it from division to multiplication by putting a dot. And then you're going to flip that bottom fraction. So then the 4 plus x, 4 minus x is going to come on top. And on the bottom, you'll have 2x. If you have done everything properly up to this point, what you should see magically happen here for you is that this x on bottom is going to cancel out with an x up on top. If it doesn't happen immediately for you, go ahead and expand the top and see what happens when you simplify it down. But most of the time, you're going to see the cancellation happening right here. So we cancel those, and then we kind of rewrite what we have again. I know it's super annoying, but you just got to keep it all written down properly for them until you get to the very end. And the better that you get, the more steps you'll kind of be able to quickly do at once. So here, we've now canceled out that common term. And guess what? We are back to option 1. Option 1 is always where we should hopefully end up. Option 1 is just plug it in. So again, we're going to take that x value of 0 and plug it in for all the x's in our equation. And when we do that at the plug-in step, that's when we finally get to drop that limit statement. So then we put that, and then 4 minus, plug a 0 in here. All of that is over 2. And so then we multiply all that out together, and we end up with what? 4 times 4 on top is 16, divided by 2 is 8. 8 times 7 would give us 56. And that's going to be our final answer. So the limit as x approaches 0 of that big equation ends up becoming y equals 56.